Hi guys, Rick Malava here with another tutorial about putting holes in cylinders and keeping with the topic of this thread. In this tutorial we're going to create what we see here. It's a barrel with a heat sink around it, or a radiator that has these holes in it. And we're going to use a slightly different method to create this one. In previous tutorials in the thread I started out looking at the idea of starting with a flat plane, cutting the holes in the flat plane, and then using the bend deformer to wrap it around to create the cylinder. And we looked at three different kinds of effects that we can create. We could create a cylinder with holes drilled in it. We could create a cylinder that looked like the holes were punched through it, and you get a sort of a divoted effect. And then we looked at ways of using the same technique to do just not round holes, but any kind of shape you want to cut into the surface at all and bend it around. Now, as an academic exercise, that works out really nice, but in practicality, in order to apply it, you would have to actually get a calculator out and do some measurements in your scene. You'd have to know the radius, for instance, from the center of the barrel out to the outer radius of this heat sink. You'd need to know the radius of each of these holes, and you'd need to know the distance between each hole as you go around the cylinder. Not difficult math, but it would still require getting out a calculator and doing math. Since a lot of artists don't like to do math, I'm going to demonstrate a method here that's more along the lines of what you would typically see in a tutorial to create an object like this. You'd start out with a cylinder, and using the Boolean operation we'd create some cutting objects and then cut the holes in the cylinder using the Boolean difference. The method that I see in a lot of the tutorials, however, starts out with a very dense cylinder for the object to be cut, and then very dense cylinders for the object to cut the holes, and then they simply just Boolean out the two objects and don't smooth it. They leave it as it is with this really highly dense mesh and all of these end guns, and they can't smooth it because it wouldn't be able to hold its shape. And then trying to go in and fix the geometry afterwards to get it to be quads or triangles would be prohibitively difficult. I'm going to demonstrate once again a method where you can use Booleans, and if you think about the way that you're going to use them, you can use Booleans and also create a nice clean quad geometry. So it's just a little bit about a thinking process of how you would do this, starting with a cylinder, Booleaning out these holes, and also ending up with a surface that's nice and clean. So with that, let's look at the method that we can use to model this object here. Okay, let's get started. So what we want to do is create this heat sink. It's got a total of 8 holes going around it. So a logical starting place would be to start with a 8-sided cylinder. So we'll create a 8-sided cylinder. And we want the holes to be offset, so we want 2 rows here, so we'll set 2 divisions in height. We'll make the squares the polygons as square as possible. Delete the end caps. Pick 2 of the faces, extrude them in. Delete the faces and smooth it to see what we get. And that's kind of what we're going for. But there's a problem. If I add the end faces back in here, you'll see what it is. And we look at it from the side, you can see that the circles are perfectly flat, so we're going to get this really flat effect. It's not going to be very circular. So instead of an 8-sided cylinder, let's start with a 16-sided cylinder and see how that would work out. So we'll once again give it 2 divisions in height, and now we pick 2 faces for each of the circles, and now we have 6 sides, so we can make those as circular as possible and see how they'll look. And we do that by creating a hexagonal shape. We can take those 2 edges and bring them in, and just to kind of get a rough idea, we'll do it very quickly, and you can see that it's going to maintain the circular shape around the cylinder much better. The problem is this is all the faces are all wonky, and we've lost planarity of those faces. So let's do the same thing. We'll start out with a 16-sided cylinder. This time we're going to use another 6-sided cylinder and a Boolean to cut out those holes and make sure that we maintain the planar surface as much as possible. So we create a 6-sided cylinder, rotate it, and we're going to go into a side view so that we can size it properly. We're going to size it the right size. We're going to rotate it 90 degrees so that two of the corners are vertical and match up with the lines running vertically around the cylinder in the two faces that we want to cut the hole. Make sure that the cutting surface is definitely inside of the two faces that we're going to boolean out, and do a boolean difference. There we go. Now this surface has symmetry, so rather than repeat a lot of work, why don't we just delete all of these faces, and using edge split we're going to split this polygon up with the hole in it so that we get a nice surface with all quads. And now we're going to just take and temporarily, we want to have an inset so that we hold a sharp edge here. So I'm going to temporarily use fill hole to add a face, and then do an extrude and do an offset of 0.01, and then delete that face. Now we've got all quads and a surface that's pretty close to planar. Now we can take this object and duplicate it, flip it in Y by setting its Y scale factor to -1, rotate it 45 degrees, combine the two surfaces, and merge the vertices. Now we've got 1/4 of our cylinder. Now take that surface, or that object, and we're going to duplicate it, rotate it 90 degrees around the origin, duplicate it 2 more times, combine it, merge all the vertices, and there we go. We've got 1/5 of our heat sink done, and it's all quads. Now let's add some length to it, so we'll duplicate and just translate it upwards. Now I could move the pivot to the edge and then snap the edges together, and I'm thinking about doing that right now, but since we're kind of freehanding this, let's just do it by eye. So we'll line the two up, and I accidentally combined them before I duplicated a couple times. So line it up once again by eye, and then let's make a couple more copies. Now let's combine all of those together, and then select all the vertices and merge them. We have one surface now with all of these nice holes in them, and it's all quads. Now what we need to do is add a barrel. Alright, we have to add some thickness, so what we'll do is select the whole object, scale it in a little bit, scale it for some thickness, and then scale it one more time. What we're doing here is creating 3 edges so that we get tight edges around the ends of the cylinder there. And now what we'll do here is we'll add another 16-sided cylinder, and this is going to act as the barrel. Scale it kind of where you want it to be. Now what we need to do is we want the heat sink to fit around the barrel, so we're going to take the end here and we're going to extrude it back a little bit, and then we're going to extrude it down so that it fits around the barrel. So the first thing I'll do is a small offset so that we hold the edge on the inside wall. We'll scale it out one more time, and then one more time to give it to tighten up the end of the barrel there. Now all we need to do is select those interfaces, and we'll scale them in to snugly fit around the barrel. I've got a couple of extra edges in here, I'm realizing, so I'm going to template the barrel to get it out of the way, and then I'm going to get rid of some edges I don't need. Select the faces, that face loop there. Now I can extrude that face loop in to fit around the barrel. There we go. Now all I need to do is get rid of some extra edges, and we need to tighten those inner edges up so that we have a nice tight corner going around the barrel there. So with those 2 edges selected, I'll just run a bevel operation here. We'll give it 2 segments, and we'll set the offset to 0.1. Got an extra edge here I don't need. I need it on the inside, but I don't need it on the outside. And now if we smooth it, we have a nice tight cylinder, and we can bring the barrel back. Now that takes care of the back of the barrel. We need to do that same thing for the top of the barrel, but once again we have symmetry, so all I'm going to do is select the upper faces and delete them. Select the bottom faces that I want to duplicate up top and duplicate those. Scale them -1 in Y to flip them. Now the pivot is right at the bottom edge, so I can just snap the edges together, rotate it 45 degrees to maintain the hole offset. Combine the two objects, merge all of the vertices, and there we go. We've got a single surface now for the heatsink. And so for the rest of the video here, we're just going to finish off modeling the barrel that fits inside. So first thing I'll do is bring the end of the barrel up so that it's flush with the front of the heatsink. And then we'll scale that face in, scale it in again, and that will represent the barrel opening. Get rid of the two end faces, we don't need those anymore. And I'm going to simulate rifling here, so I'm going to select every other face inside the barrel, and we're going to extrude those outward a tiny amount. There we go. Now I'm thinking here how I can keep the edges tight, but I don't want to put a whole lot of geometry in here, so I could extrude it again, but as I think about it, what I think I'm going to do is just scale them in so that they don't come straight flush with the end of the barrel like that. So I'll give them a slight taper inward, and then along the length of the rifling I'll taper those in a little bit as well. I was thinking about adding another offset in there, but once again I don't want too much geometry in here. So to tighten these edges up, I'm just going to throw edge loops around the top and bottom of each of those extrusions. I could have done this by extruding several times, but it's such a tiny amount in here, it's just easier to walk around it. Now as you can see, the barrel's not holding its shape at the end, so what I need to do is I need to throw some edge loops in there to hold its shape. So we'll just throw a couple edge loops in here. I could bevel those edges, or I can just throw edge loops. Remember, you need 3 loops to create a tight edge, and here I realized that I can't maintain the third loop because the rifling is coming right to the end. So I'll just grab the whole end of the barrel, shift the selection up 1, extrude that whole thing out a little bit. Now I've got an extra edge back there I can get rid of, and now I have 3 edges going around the barrel, both on the inside and the outside, and we get a nice tight corner there now. I'll just continue putting the edge loops around the rifling, one at the top and one at the bottom. It's not giving us a full 3 edges, but it's going to be tight enough that from a distance you'll have the illusion that you have rifling inside the barrel, and the edges will be fairly tight. Okay, there we go. Now the only problem is rifling doesn't run straight down the barrel, so what I will do is select all of the vertices at the end of the barrel here and just bring up the rotate manipulator and give them a twist. There we go. A little too much there, and took the little bit of that twist out. Then what we do is grab all of the faces at the bottom and delete those, because we don't have to worry about tightening up the edges at the back of the barrel. You'll never see it. Pardon me. And so there's the barrel. You get a nice rifling effect illusion on the inside, and we'll bring back the heat sink. Let's apply a shader. I've got a Fong shader with sort of a gunmetal color on it. We'll group all of those 2 pieces together and do a quick render here. I'm cleaning up some nodes that were empty nodes that were left over from some operations. And we'll just frame this up and do a render. Thank you for watching, and I hope you found this to be something of use.